Hey, welcome in the third part of the roller coaster tutorial. If it's not done yet, check out the first and second part to see how we ended up here. Now that we set up a line system for the pillars, we need to make it look cool, complex and easy to tweak. To do so, I will show you how to use for each loops and polygon operations to mesh all those curves. We also add complex expression to randomize and control the look of the pillars. You are in for a fun time, my friends, so let's dive in. So that's where we stopped last week. We're gonna go back to the tripod section and add a polywire. So this node basically gonna convert the line into a tube. We can add 24 division and reduce the wire radius, something that's a bit more decent. So just like past week, we're gonna use the for each primitive loop to go through every curve that we have and drop a carve node. So this carve node is gonna trim the curve, and we're just gonna keep the top by enabling second U, like so. That's great. So now if we drop a polywire and mesh that, let's increase the division to 24, and for the radius we can just copy the parameter that we had in the first node and just paste it as a relative reference into the new polywire. We can also give a color to the node so that we can remember where is the master parameter. From there, let's multiply this parameter by 1.2 so that it's a little bit bigger than the original node. And we can merge those guys together. Yep, that's better. Now we have a nice top section. We can add some detail by adding a group node to isolate the bottom face. So let's keep it to primitive and we're gonna name it bottom. Let's check keep binormal and set the direction to -1. If we change the spread angles, we can have like a kind of threshold that allow us to isolate this face that's pointing toward the normal -1 direction. So that's cool. If we drop a poly extrude, use the bottom group and increase the distance, we can now have a little, yeah, that's better. Let's export the side group so that it export the new face into a new group. And let's grab this extrude side group into a new poly extrude. So now when we increase the distance, it's like making this kind of ring. Tweaking a little bit more the values, that sounds alright. So let's export the front seam, and now when we drop a poly bevel and grab that front seam, you can actually get a smoother kind of thing. So let's drop the division to 1. If we want, we can do the same with the top. So let's just like do the same group top. This time the direction is 1 in Y because it's like pointing to the top. If we decrease the spread angles, right, it's showing up now. Now the thing is, like, it's also selecting the new face that we just created, and we don't want that. So let's just copy and paste it into the beginning of the hierarchy. So now if we poly bevel this group that we call top, we just get the bevel at the top edge kind of thing. We can change the shape in round and it's looking cool. So if we check out everything, it's looking pretty sweet. It's a good base. Now if we check out the reference, we may want to add some kind of randomness in that. So to do that, let's go back to the carve, and we realize that we may want to vary this parameter. To do that, let's create the metadata of this loop. Right, so we see if we middle click, we get some attributes inside, iteration and number of iterations. So we want to use the iteration attribute to apply a specific value to each line in the loop. To do so, let's create an expression. So we're gonna call this attribute by using detail, and let's type, we want to grab the for each metadata that we have, and the attribute we want to call is iteration. The default value will be 0. What we may want to do though is randomize this parameter. So we can add a random function. To create some control, we need to fit the random values between certain number. So we can use fit01 function, and all this random stuff gonna be refit between, let's say, a value of 0.1 and 0.3. Great, so now we got a value of 0.1 and 0.3 inside the curves, and we can actually create some controllers. So we can drop a parameter called minimum distance, another float that we can call max distance, and the last one called seed. Now if we try to copy the parameter and feed that into our expression, so we're gonna try to, okay, so it looks like I can't right click into that, so just gonna take this one and temporarily paste it and cut it into my expression. That's cool. Can copy paste and just change the name manually to max distance. And the seed, we're gonna actually add it at the end of our random function. If we add a multiply by seed, we end up with some control that allow us like an infinity of variation. Like if we change the seed, you can just try to find a value that sounds right to you. Yeah, why not? So it's pretty much matching the reference we had. Now we can start working on the beams. So in the pillar tripod section, let's add a for each primitive. Right. So we can drop a curve node. Now we notice if we change the first two value, it's gonna trim the curve, let's say around the middle. And we wanna actually try to preserve the first point that's like in the middle. The point number is 0, so let's not forget to switch the group type to points. Now if we blast the points and we just keep the beam points, we end up with the triangle shape that we had before. If we try to connect those points with a add node, well, that's a bit, let's switch to group of n points and set n to 3, so it's connecting. Actually, I realized it would be easier to connect this section to the previous loop we had before. Yeah, now we end up with just separate triangles, and we can create a primitive between each point, which might be easier to control later on. So basically I'm just trying to reshape my connection to get two primitives, merge them together, and let's drop a group, but not enough room, so let's expand the graph. So I'm creating a group that I'm gonna call beam for the primitive we just created. Okay, let's reorganize a bit and merge this guy with the primitive, with the previous primitive we had. If we check out how it looks, well, I actually forgot something. Yeah, should actually delete non-selected. Yeah, looks better now. If we try to change the curve value, it's looking way better. Let's correct something now. We should blast the primitive beam for this section. Sweet, and let's copy and pass the node, delete non-selected, and we just give the triangle shape in which we're gonna make a loop. Great. And add a polywire. Let's crank up the divisions. And we can actually copy the radius parameter and paste it into the new polywire and multiply that by something like 0.9, so it's like slightly smaller. Now we're gonna need to isolate the largest faces to make some polygon operation. To do that, let's drop a measure node. We need the perimeter, and if we check out the spreadsheet, we realize the small faces on the side, the caps, are around 0.1. We could also use the primitive number to isolate them. For now, let's just use the measure node so I can show you the group expression. So we can drop a group expression in which we're gonna call large faces. Right, and the vex expression gonna be at perimeter greater than 0.2, because the small faces are around 0.1 something. If we want to be safe, let's just say 0.5. And if we try a poly extrude and call the group we created, we can now insert some new edges. So let's display the wireframe. So that's too much, so I decrease, and let's do something like that and export the extrude from seam. This way, if we create a poly bevel and call this new group, actually managed to make some new loops in which we're gonna export their primitives and use those bevel prims to create the rings. Awesome. Yeah, something like that sounds better. Same thing there. Let's export the front seam. Let's call that 2. And once we call this group in a poly bevel, we can actually round the edges of those rings. Yeah, let's change the shape to round and decrease a bit. So we can cool. We can now merge that to the rest of the model. Sweet. Let's make some room and create a metadata for those beams. So if we drop a transform and actually try to change the height, we see that it's not gonna follow the shape of our pillars. That's unfortunate, but we can actually solve that by projecting the points to the curve rig that we have. So, okay, so I think I forgot to blast my beams there. So let's just keep that and plug the collision to those splines. Change the method to minimum distance, and now if we try to change the height, it's actually following the shape of the pillars. So kinda realize that we have a double thing going on. Just forgot to plug the blast node to the main section. Now that we are blasting the useless primitive, we end up with the proper result. We could introduce some randomness. To do that, let's copy the expression we had in the carve node. So, yep, copy. And into the transform of the beam in Y position, let's pass the expression. We may want to change the name of the metadata to whatever you have and recreate the controller we have in the carve node. So min distance, max distance, and seed. So let's introduce some values. We could say 1, -1, and change the seed. Maybe actually too much, so let's try 0.5 and -0.5. Yep. So looking cool. We just made a mini tool to vary the position of this beam. We still have a bit of work though. top of the pillar, we're gonna create a null that we're gonna call pillar top, just to organize a bit, and drop a poly wire. So let's find the main poly wire that we had, the orange one, copy the parameter, paste relative reference, and add some divisions in it. So we're gonna try to isolate the gaps again. Let's try again the technique we had with the normals. So in that case, it's not really working. So let's just drop a for each connected piece loop. If we get inside, we see that the gaps face number is 0 and 1. So let's just make a group where we're gonna create a bottom group with the 0 primitive and call this bottom group into the poly extrude. So now if we change the distance and maybe the inset, we can actually kind of link everything together. Let's create another group that we're gonna call top with the face number 1 and poly bevel this top group. Sweet. Not the most elegant connection, but for an introduction, it will do the job. Now, we got those two legs pillar. Let's just simply copy the poly wire of the top to this one. Sweet. Gonna apply a bit of color in there. Like, let's drop a color node. And we're gonna put some pink. Since our reference was pink, let's just do that. And here's gonna be blue for the pillars. Yeah, actually not that blue, that's more cyan. Cool. I hope that you guys understood the fundamentals of procedural modeling. We could actually like go further and add some more complexity to the models, like add some details, bolts and everything. Like if we look at the reference, we have some other shapes we could add. With what I just showed you, you should have all the tool in hands to go ahead and start figuring out things by yourself. Unless I completely fail, then we'll need to make more tutorials. Which I will do anyway. Next week will be time to do a break with Houdini tutorials, and I'll start to show some more techniques with another software I really enjoy using, which is Blender. So preparing some exciting content, you know the drill, stay tuned, don't forget to like and subscribe. See you guys next week.